Hi, everybody. Today is Monday, December 6th. In class today, I talked very briefly about the rock transformations test. If you were absent the day we took that test, I need you to communicate with me to find out when you're going to be able to take it. We also started our last, it's not really a unit, this is our semester final project. And this is something that Amplify does. I think they're super cool. Basically, it takes everything that we've done in the units and you apply it to a scenario in which you are trying to find a solution to a real world problem. And so this one is called Plate Motion Engineering Internship, and I'm just going to go ahead and go through real quick and introduce the project to you. So today, you're going to be working as an engineering intern for a company called Futura. And you're going to start each day of your internship by reading a new message. Now, I'm going to have to, I will embed a video that shows you how to log on. It's a little bit different. If you are absent and you cannot figure this out, when you come back, make sure and let me know that you are not able to log on, and I'll make sure and show you how to log on to this. It's different than what we've been, where you just go to the table of contents and click in the unit. This one's a little bit different. You have to navigate a different place. Okay. This internship will take place over the next 10 class periods and will be incorporated into your semester final. You're going to use what you already know about geological events, volcanoes, earthquakes, and plate motion to help you solve a real world problem. Now, you may be working alongside your fellow interns using both digital and physical models. However, you will work independently to write a proposal based on your own research. The written proposal is your semester final. It will be worth 100 points. I'm going to talk about that a little bit more in detail in a couple slides. We are on a really tight schedule. We have to work really diligently to make sure that we meet all of our deadlines. So make sure that you keep up with all the daily requirements and after hours work. You're an intern now, so you are no longer a student. It's not called homework. It's called after hours work. You will be assigned to MSAP if you miss a deadline, just like any job. If you don't get it done, you don't leave until it's done. All right. So I am what's called your internship coordinator, and it's my job to guide you through this project. Let's begin. Okay, so in class today, we talked really quickly about the word engineer. Has anybody ever heard of an engineer before? What kind of work do engineers do? And then specifically, I kind of led the discussion about what geohazards engineers would do. And if you look at the word geohazards and you break that up into their prefix and root word, geo is earth, hazards, it's not a good thing. So maybe we kind of came to the conclusion that all engineers do design solutions to problems. So there's building engineers, there's chemical engineers, all kinds of different types of engineers, and they design solutions to problems. You will be working as a geohazards engineering intern at Futura, and a geohazards engineer applies concepts from earth science and physics to help minimize the impact of natural disasters. So we took a little bit of time. We talked about what exactly are some examples of natural hazards and how do people prepare for them. So if you look at the picture, you could see maybe one example of a natural hazard would be a hurricane. Well, how do people prepare for a hurricane? Well, we have a weather report days in advance. They use satellite systems. They track the storm. They see where they think, they make predictions about where they think it's going to make landfall. People are given warnings days in advance, and they will evacuate if that's the case. So that's an example of natural hazards. Tornadoes are examples of a natural hazard. And again, we may not have days to prepare for a tornado, but we do have a tornado watch and a tornado warning. And the difference between those, a watch says, hey, the conditions are right, be ready. And a tornado warning says, hey, there's been a funnel cloud located in your area, in your immediate area, take cover now. So you have a project director, and her name is Hannah Wong. And I'm not going to play the videos for you. But she explains more about Futura and about the engineering project. I'm going to skip a couple slides for you guys. Basically, um, we are going to be trying to design. I say we, I mean you. You are going to be going to be designing a tsunami warning system specifically for the people in an island called Sri Lanka. In 2004, there was a horrible tsunami that occurred, and over 200,000 people were killed. 200,000. That's a lot of people. And so, in order to kind of, as a result of that, there were some warning systems put into place. However, they're not perfect. And so, as a geohazards engineer, your job is to see if you can create something a little bit better. So, Hannah Wong is the project director for this internship. Every day, she will send you messages. She's going to assign you tasks to do and give you feedback on your work. Okay. And again, I will show you where to access that when you come back from being gone. So your internship will have 3 phases. And remember, we have to do all of this within 10 days. So there are 3 phases: are research, design, and proposal. And I'll give you a quick overview of what happens at each phase. So during the research phase, you are going to look for information to understand the problem that you're trying to solve. So first of all, you have to understand what a tsunami is, what causes a tsunami to form. You have to learn what types of sensors are used now so that you can design an improved tsunami warning system for the World Ocean Administration. And ultimately, you're doing this so that you can warn the people of Sri Lanka of an approaching tsunami. During the design phase, you're going to actually test your design. This is the fun part. This is where you get to do the science part. We have digital, like a computer simulation. It's a little bit different than one that you've done in the past. And then we also have like a real hands-on 3D physical model of a tsunami model. And so you're going to use those to apply the research that you did towards planning, building, testing, and finally analyzing your warning system. And then lastly, during the proposal phase, you're going to write a proposal describing the evidence from the research and test that you did, how your warning system design addresses the project criteria. And we'll talk about criteria in a second. This is what your semester final is going to be. So remember, we have 90 minutes for our semester final. And during that 90 minutes, you will write a proposal saying, this is what I did, this is the best design I think that I could make, and this is what I think you, Futura company, you should design this, you should make this, you should sell it, this is what our product should be. Okay, I'll explain more about that later on. Don't freak out about that. Right now, we're just in the research stage. All right, so criteria. We have 3 different criteria. Criteria is a standard by which something may be judged. And at Futura, we have many different criteria for every project. Specifically for this project, we have 3 criteria for your warning systems. And we talked in class about why each one is important. I'll just summarize that for you. The first criteria or requirement is that you need to maximize average warning time. And of course, that's important because the more time we have to give people a warning, the more likelihood that they would be to find a safer place to be and not close to the beach. Remember in Sri Lanka in 2004, 200,000 people passed away because they just didn't have the warning. They drowned. It was awful. So we want to make sure that we maximize average warning time. The second criteria is that we want to minimize false alarms. And in class, we talked about why would it be a big deal to minimize false alarms? Well, a false alarm is when a warning goes out, but nothing happens. So think about how many times you hear a car alarm and people just walk by. Sometimes we don't even look at what's going on there. Like there have been so many times that there have been like a false warning or a false alarm, but people don't pay any attention to them. So if your warning system gives off a lot of false alarms, people aren't going to pay attention. So when there really is a tsunami, that could have catastrophe, that could have devastating results. And then the last criterion is to try to keep the cost low. And we talked about this because if this is something that is going to be implemented, we not only have the costs of making the product, but you also have costs of maintenance over the years and costs of false alarms that cost people money because people drive away and so anyway we want to keep costs low too. These are the three things that you're going to be looking at and trying to really make sure that you meet the needs of all three of these criteria. Throughout your internship, you're going to be using something called Futura Workspace to get messages, record notes, and submit work. This is where in class I had somebody project this up on the board. We went through it. If you are absent today, it's just too confusing for us to do this via video. So when you come back, come see me and I'll take you through real quick. It won't take very long for you to get a little tutorial. All right, so then we have something called after hours work. Each of the students received a paper copy of this Futura Geohazards Engineers dossier. A dossier is like a workbook. It's something that people use in the workforce to say, okay, this is all the information that you need to have. For this task, this is your homework, but you're not a student, you're an intern. So this is your after hours work. You need to read and annotate. Annotate. Okay. You're going to read chapter 1 and chapter 2. I think it's a total of 5 very short pages because there are a lot of graphics that go along with this. It's something definitely you can do. I don't imagine that it'll take more than 20 minutes at the very most to get it done. So go ahead and do that. Be ready to discuss if you are able to come back to class tomorrow. If not, hang on to your annotations and then watch tomorrow. I'll have a video that kind of summarizes what we did in class again. Okay, take care. Hope to see you soon.